Day 572 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2435, paths in matrix whose sum is divisible by k. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you get you some. Now let's see what the question says. You are given a zero index n by n integer matrix grid and an integer k. You are currently at position 0, 0, and you want to reach position n minus 1 and n minus 1, moving only down or right. Return the number of paths where the sum of the elements on the path is divisible by k. Since the answer may be very large, return it in module 10 to the 9th power plus 7. All right, y'all, so that may seem a little bit confusing at first. So let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. Now, first thing I want to do, though, before we get into these examples is I want to handle this right away just so I don't forget later on. So we're just going to say let mod base equal 1 underscore 0, 0, 0 underscore 0, 0, 0 underscore 0, 0, 7. Boom. Now let's take a look at these examples. So in example 1, we have our input grid equals a 2D array of integers. First array being 524, next array 305, and then the last array is 072, and k equals 3. The output is 2. Now before we look at the explanation, let me just break this down to y'all so y'all understand. Each one of these arrays represents a different row in this grid, right? So 524, that is the first row. 305, that is the second row, and 072, that is the third row. Now let's take a look at the explanation to see how they got an output of 2. And remember, we want to find a path whose sum is divisible by 3. So let's see. It says there are 2 paths where the sum of the elements of the path is divisible by k, which in this case is 3. The first path highlighted in red has a sum of 5 plus 2 plus 4 plus 5 plus 2, which equals 18. So as you can see, this is the first path from 0, 0 to n minus 1 and n minus 1. So this, we're only going right and down, and this is the first path we take. This path right here highlighted in red has a path of, or has a sum of 18. 18 is divisible by 3, so that we can add that to our count. We found one path. Then it says the second path highlighted in blue has a sum of 5 plus 3 plus 0 plus 5 plus 2, which equals to 15, which is divisible by 3. So this is the second path right here. Once again, we're only moving down or to the right, and this path has a sum. When we add up every element in this path, we get 15. 15 is divisible by 3 as well, equals 5. So since we have 2 paths that we can add up the sum of the path, and that the sum is divisible by k, which in this case is 3, we return 2. So remember, we're not returning the paths themselves, we're just returning how many paths we can create that have a sum that is divisible by k, which in this case k equals 3. And in this case, we can create 2 different paths out of this grid, this initial grid right here. Boom. So that's our output is 2. So just in case that didn't make sense, let's take a look at example 2. So in example 2, we have our grid equals an array of integers 0, 0, k equals 5. The output is 1. It says the path highlighted in red has a sum of 0 plus 0, which equals 0, which is divisible by 5. So anything divisible by 0, that's, I guess we're counting that, because anything that is divisible by 0 would be 0, right? So if we divide 0 by 5, we'll get 0. So I guess that still counts, and that's why the output is 1, because that still counts as a good or counts as divisible when we do 0 divided by another number, because it's going to equal 0. So let's take a look at example 3, where it's a little bit trickier, or I'm not gonna say it's trickier, but there's a lot more solutions or a lot more paths we can create. So In example 3, we have an input grid equals an array of integers 2D array of integers 7, 3, 4, 9, 2, 3, 6, 2, 2, 3, 7, 0, k equals 1. Our output is 10. It says every integer is divisible by 1, so the sum of the elements on every possible path is divisible by k. So in this case, since k equals 1, then that just means uh, uh, every path that we take is going to be divisible by k because k equals 1. So I guess there are 10 different paths we can take to get to this from 7 to 0. So that's why output is 10. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Y'all, solution is not that difficult at all. Now, first thing we're going to do, we already handled our module base requirements. So now we're going to move on to getting the number of rows and the number of columns. So we're going to come right here and we're going to say let m equal grid dot count, and that's going to get us the number of rows. And then we're going to say let n equal grid square bracket 0 dot count. Boom, and that's going to get us the columns. Now we're going to create a 3D dynamic programming table, which is going to get the number of ways to reach each cell such that the sum of the values along the path mod k equals x. So in this case, we're going to declare a variable called dp, set that equal to an array. Open up the parentheses, we're going to say repeating colon array. Open up the parentheses, that's going to be repeating colon 0 comma count colon, that's going to be k. Then we're going to come outside those parentheses, we're going to say comma count. Oh, sorry, this is going to be a 3D array, so we need the let's do this over right here. This array is going to be repeating another array. Then we're going to open up the parentheses, and that's going to be repeating colon 0 comma count colon k. Then we're going to come outside of that. These parentheses, we're going to say count colon n. Then we come outside these parentheses and we're going to say count colon m. Just like that. Boom, that should be right. I guess we'll find out when we run it. Now we're going to start at 0, 0. So we're going to say dp square bracket 0 square bracket 0. Then we're going to say square bracket grid. Come outside of that, and still inside the square brackets, but next to grid we're going to say square bracket 0. Come outside of those square brackets, we're going to say square bracket 0 again. Come outside that, and we're going to say mod k, and we are going to set that equal to 1. Boom. Then we're going to iterate over every cell in the row. So we're going to say, come underneath this, we're going to say for r in 0 dot less than m, we're going to open up the brackets. Then we're going to say for c in 0 dot less than n, we're going to open up the brackets. And for each possible remainder state, we're going to say for mod val in 0 dot less than k, we're going to open up the brackets, and we're going to say let ways to get to current equals dp square bracket r square bracket c square bracket mod val. Boom. Then if no paths reach this state, we can skip. So we could come underneath this and we'll say if ways to get to current, current equals 0, then we can open up the brackets and we can just continue. Boom. Then we'll come underneath that and we'll try moving to the right. So we'll say if c plus 1 is less than n, then we're going to open up the brackets, and we are going to first we need to store a new remainder after adding the next cell value. So we're going to say let new remainder equal, open up the parentheses, grid, square bracket R, square bracket C plus 1. Come outside those square brackets, we're going to say plus, sorry y'all, mod val, come outside of that, these parentheses, and we're going to say mod K. Boom, then we need to add the number of ways to reach the new state by coming underneath this. We're going to say dp square bracket R square bracket C plus 1. Come outside of that, square bracket new remainder. Come outside of that, we're going to set that equal to, open up the parentheses, dp square bracket R square bracket C plus 1. Come outside of that, square bracket new remainder. Come outside of that square bracket, we'll say plus ways to get current, and then we are going to say mod, sorry y'all, let's say mod base. Boom. Then all we have to do, or sorry y'all, not yet, moving too fast, because we still need to try moving down one. That's moving to the right. So to move down one, we need to come underneath this, and we're going to say if R plus 1 is less than M, then we're going to open up the brackets, and we are going to say let new remainder equal, open up the parentheses, we're going to say grid, square bracket R, plus 1, come outside of that square bracket, we'll say square bracket C, come outside of that square bracket, we're going to say plus mod val, come outside of those parentheses, and we're going to say mod K. Boom. Now we're going to accumulate the different ways mod 10 to the 9th power plus 7 by coming underneath this, and we're going to say dp square bracket R plus 1. Come outside of that, we'll say square bracket C. Come outside of that, we're going to say new remainder. Come outside of that, we're going to say equals. Then we're going to open up the parentheses. We're going to say dp square bracket R plus 1. Come outside of that, square bracket C. Come outside of that, square bracket new remainder. Come outside of that, we're going to say plus ways to get current. Then we're going to say mod base. Boom. Then the answer is the number of ways to reach the bottom right with the remainder of 0. So we're going to come down here, and we are going to say return dp square bracket n minus 1. Then we're going to say square bracket n minus 1. Come outside of that, we'll say square bracket 0. Boom, y'all. That should be all she wrote. Let's give it a run. I know there was a lot going on in this code. So it says, let's see. So we need equal white space here. So let's run that again. See if that fixes anything. Okay. Ways to get current. Cannot find ways to get current and scope. So ways to get to current. Oh, ways to get. Let me just see. Okay, so we need to add this 2 here. We need to add this 2 here. So run that again. See if that fixes it. It's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Wrong answer. Okay, y'all. So we got the wrong answer. So somewhere the math isn't mathing, right? So let's see if we can figure it out. where the math went wrong. Okay, y'all, I think I found a problem. I think I need to move this mod base right here. This needs to be outside of the parentheses, and same with this mod base right here. This needs to be outside of the parentheses as well. So now let's give this a run, see if that did the trick. Let's see, it's accepted. So now let's submit it and make sure it's still accepted after we submit it. Let's see, and look at that, y'all. 219 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, make sure you get one more look at the code. This is the top part, and this is the middle part, and this is the bottom part, y'all. And yeah, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.